If you have any questions, comments, please just let me know. Today we start talking about quadratic functions. So in the previous several lectures, we've been heading into the world of functions. So we discussed what the definition of a function is. We've talked about the domain and range of the function. We've talked about how to combine functions with addition, subtraction, multiplication, and division. Then we started discussing about composition of functions when we apply one function to the next, to the other function. And then we started talking about one-to-one functions, which led us to what's the idea behind inverse functions. So again, like I said in the beginning of the semester, pre-calculus is all about functions. And we have also discussed, I forgot to mention, transformations of functions, which is also extremely important, and the different parent functions. So we're going to be now heading into a specific field, I guess, or category of functions, and they're called quadratic functions. And I know most of us have had experiences with quadratic functions. And then after we discuss quadratic functions, we're going to deal with the more general type of function called polynomial functions. Quadratic functions are a specific subcategory of what are called polynomial functions. Okay. So first I'm going to discuss what the general form is. So what is the general form of a quadratic function? It looks like this. So it's f of x, right? This is from my function notation. This is equal to ax squared plus bx plus c. Now, a, b, and c are all constants. So the parenthetical remark I make is that a, b, and c are all real valued constants with the extra condition that a does not equal 0. And I'm pretty sure many of us have seen this already, right? F of x equals ax squared plus bx plus c. Am I right, or am I? Can you tell me if you guys have seen this before? Yes, 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 yes. Okay. Great. Now, what kind of information can I gather just based upon this form? So there's several pieces of information that I can figure out. So this is what the general form gives me. So this is the information of quadratic that can be found from the general form, from its general form. So what can I find about, what can I discover about a particular kind of function if I'm given the general form? So the first thing I can immediately tell, I can tell whether or not the function has a maximum or minimum. So number one is that I can determine whether the quadratic function has a maximum or minimum value. Does anybody know how I'm able to determine this? Anybody? Using a graphing calculator, correct. However, what happens if you don't have a graphing calculator? We can determine whether it has a maximum or minimum value without a graphing calculator. Just by looking at the function, I'm able to tell, oh, this is a maximum, or this will have a minimum. Yes, Cindy, that's right. It's all about that A value. This A value is what tells me. So then how do we determine? Well, we determine it by the what's called the leading coefficient, by the sign of the leading coefficient. And this is just fancy words, and we'll talk more about what leading coefficient is. It's just fancy words for saying what's the number in front of the highest, the term with the highest power. So of course 2 here has the highest power. So this A here is considered the leading coefficient. So I want to know what A is. So what do I have is the following. If A is positive, then what am I going to have? If I have a positive A value, then when I graph my function, I'm gonna have something that looks like this. If A is positive, right? So it means positive. Then I have, this is the graph, and I have a minimum value, which means that my graph or parabola opens up. Parabola opens upward. And all I had to know was whether the A value is positive. However, it could be, so I'm gonna call this I, it could be that my A value is not positive. It could be that A value is negative. Then what? Then when I graph this, I have a maximum value. So I have a maximum value, which means that my parabola opens downward. So just by looking at the A value, I'm able to determine whether a graph opens upward or downward. And if it opens upward, then I have a minimum. If it opens downward, I have a maximum. So that was the first thing I can find. Okay. Now, the second thing I can find, based upon the general form, is the following. I can figure out what's called the axis of symmetry. Does anybody remember what the formula is for the axis of symmetry? Does anybody know what the axis of symmetry is? No? Nobody has no one heard about the axis of symmetry? Okay, good, Sydney. Sydney. So, what is the axis of symmetry? Or what do you remember about the axis of symmetry? Does anybody remember the formula for it? Negative b over 2a. Very good, Cindy. There's Sydney and there's Cindy. Cindy, yes, negative b over 2a. So that is the x value. X equals negative b over 2a. That's the formula for the axis of symmetry. And what is the axis of symmetry actually? It's is the formula. So this is the formula. This is the formula for the vertical line that divides the parabola into two equal parts and goes through the vertex of the parabola. Now, what is the vertex of a parabola? The vertex of the parabola it's either the maximum point or the minimum point. So it's either the max or min point of a parabola. So that's what the vertex is. So in this case, my vertex is that minimum. And what do I have? I have a vertical line I'm going to create as a dotted line, as a dashed line. So this here would represent the axis of symmetry. And this is my vertex. So that's one thing. That's another thing we can find out based upon the general form is the axis of symmetry. So not only does it divide the graph in half by going through the vertex as a vertical line, this also, so note, the axis of symmetry is, I'm going to put this in capital letters, is the x-coordinate of the vertex. So we'll find out more about this. When we want to find the vertex, the coordinates of the vertex, we have to include this idea of the axis of symmetry. So once we find the axis of symmetry and we know what the x value is, to find the y coordinate, we have to plug in the x coordinate for the axis of symmetry into our function to find the y coordinate. So that's the connection there. So far, we're able to figure out whether the graph of the function opens upward or downward just based upon what the sign of the leading coefficient is. If it's positive, opens up, has a minimum. If the sign of the leading coefficient is negative, you open downward and you have a maximum. And then we discussed the fact that we can find what's called the axis of symmetry, which is a vertical line that divides the parabola in half and goes through the vertex and also represents the x-coordinate of the vertex. And what else can we figure out based upon the information I'm given? I'm also able to figure out are the intercepts, in particular the y-intercept. I can figure out the y-intercept. How do I figure out what a y-intercept is? Well, plug in x equals 0, right? Isn't that what we do when we find the y-intercept? So if I plug in 0 into my equation, what's the result of plugging in 0? Well, if I plug in 0, 0 squared is 0 times 8 times any number is 0, plus b times any, plus 0 times b, or b times 0, and b can be any number. So 0 times 0 again, we get 0. And the result is c. C is our constant. C is the constant value. So I'm going to write that up here as well. So C is a constant, which means that the y-coordinate or the y-intercept has the coordinates 0, c. So what can we figure out based upon our general formula for the quadratic function? We can find out where exactly it crosses the y-axis by looking at what the constant value is. So that's a pretty quick information that I'm able to find out. And then lastly, last but definitely not the least, are the x-intercepts. They're also known as AKA the roots, AKA the solutions, AKA the zeros. So how do we find the roots, the solutions, the zeros, the x-intercepts of the quadratic? Does anybody know? I think all of you should know this. It's a very famous formula that's associated with the quadratic function. And that is the quadratic formula. So the quadratic formula, as many of you may have known, utilizes all of the constants given in the general form. So based upon the general form, I could figure out whether the graph opens up or downward. I can figure out the axis of symmetry. I can figure out the y-intercept, and I can figure out the x-intercepts. Good, Felipe. Yes, this is something most of you most likely have seen and have heard and have used before. But just make sure you remember also not just the formula for the sake of it, but also understand why we even care about it. What does it give us? It does not just give us the x value. It gives us something more. It gives us the x-intercept where it crosses the x-axis. It gives us the solution to the function and so on. Okay. So let's see this in action, okay? So now that we have this kind of information, I'm going to give you a specific function that's quadratic. And it's going to look like this: negative x squared plus x plus 2. So the first thing, when I'm given, this is my general form, right? This is my general form of a quadratic. Then what am I interested in? I'm interested in the coefficients. So first I want to find all or identify coefficients. So what do I know? I need to know the A value. I need to know my B value. I need to know my C value. And I just have to look at the function and realize that my A value is negative. My B value is 1, and my C value is 2. So there we go. I got my A, B, and C value. And now I want to go through the things that I'm able to figure out. So the first thing is, does it have a maximum or minimum? Well, I have to figure out what the A value is. The A value is negative. So I'm going to write this as a negative. So then I'd say, since my A value is negative, then the function f of x has a maximum value and its graph, which is the parabola, opens downward. So boom, that's the first thing I can figure out based upon the coefficient, the leading coefficient. What's the second thing I can figure out? I can figure out the axis symmetry. Now, what's the axis of symmetry again? X equals negative b over 2a. The b value is 1, so I'm just going to plug in everything. And what do I get? I get x equals 1/2. So the vertical line of x equals 1/2 cuts through half of or divides the parabola in half and goes through the vertex. And we'll come back to that. Number 3, I can figure out the y-intercept. And that's probably the quickest thing to figure out because all we need to know is the coefficient, the last one, which is a constant, and it's 2. So then the y-intercept is obviously 0, 2. So that was quick. Then the fourth one is the what? The x-intercepts. So I need to use a quadratic formula. So my b value is 1. So this will be -1 plus or minus the square root of 1 squared minus 4 times -1 times 2 all over 2 times 1. Pardon me, -1. And then I get -1 plus or minus the square root of 1 plus 8 over -2, which equals -1 plus or minus the square root of 9, which equals -1 plus or minus the square root of 3, which is the square root of 9. And then I have two possibilities, the plus or minus, right? So if I add -1 and 3, what do I get? I get 2. So I get that x equals 2 over -2, which equals -1. And if I subtract, I get x equals -4 over -2, which equals 2. So then what are my x-intercepts? My x-intercepts are going to be, well, let me just write this out. So x is equal to -1 and x is equal to +2. So these are my two solutions or my roots. And so then what are going to be my x-intercepts? My x-intercepts are going to be -1, 0 and 2, 0. Again, remember the x-intercepts are the x-coordinates where the y-coordinate is 0. And alternatively, y-intercepts are the coordinates where the x-coordinate is 0. If it is not a perfect square, can we just leave it like that? Well, yes. If it's not a perfect square, then you're going to try to simplify the radical as much as possible. And if they're more specific in saying, hey, give me the approximated value, so you would have to approximate using a graphing calculator or some kind of calculator that computes radicals or square roots so you can get the decimal approximation for it. But yeah, so these numbers here produce a very nice kind of x values, right? They're whole numbers, but of course, they're not always going to be whole numbers. They could be fractions, they could be irrational numbers. So that's the idea. And I said I was going to come back to the axis of symmetry because based upon the axis of symmetry, right? This is also known as the x-coordinate. This is also the x-coordinate of the vertex. So actually, I can actually figure out what is the y-coordinate of the vertex as well, associated with the axis of symmetry. So this is another thing I can figure out, the y-coordinate. So how do I figure out the y-coordinate of vertex? Well, I know the x-coordinate of the vertex. I know the x-coordinate, and I know my function, what it looks like. So I have to plug in. So to find a y-coordinate, I need to plug in. Plug in what? The x-coordinate. So then I get negative 1/2 squared plus 1/2 plus 2. Now 1/2 squared is 1/4. It's negative 1/4 plus 1/2 plus 2. And if you take negative 1/4 plus a half, so taking a half and subtracting a fourth from it, I'm left with 1/4. So 1/4 plus 2 is 2 1/4, or in other words, 2.25. So then what are the coordinates of my vertex? My coordinate's going to be 1/2, comma, 2.25. Or if you want to leave everything as a fraction, let's do that. So this also is equal to, I'm just going to give you the fraction version, 5/2. So either, no, it's not 5/2, sorry, it's 5/4. What I meant to say is 9/4. So it's 9/4. So either I leave it all as fractions, so the coordinates are 1/2, comma 9/4, or you can write it as 0.5, comma 2.25. So these are the coordinates of my vertex. Okay, so these are all the pieces of information that I can figure out about this quadratic. And now that I know all these different pieces of information, I can give a pretty darn good sketch. So number 5, the last thing we do is find what the sketch is. So now we can sketch the graph of the quadratic function. So I'm going to graph it, draw the axes, the y value, the x value, and then I'm going to plot the points. I'm going to plot 0, 2. So 0, 2 is 1, 2 is right here. This is 2. And then I'm going to plot the x-intercepts, -1. So -1 is right here. -1, 0. And then 2, 0. I got 1, 2. Then I'm gonna just sketch the 1/2 which represents the axis of symmetry. So this is my axis of symmetry. And the function, the equation is x equals 1/2. So this is 1/2. And then based upon this axis, I'm able to figure out that the y coordinate is 2.25. So the associated y coordinate is right there. This is my vertex. And my vertex has the coordinates 1/2, comma, 9/4, or in other words, 0.5, comma, 2.25. And then I can graph. I can just sketch the graph by connecting the points. I know this is going to be opening upward. Something like this. And this will have the other half. And voila. I've sketched the graph. And I'm just going to label the points. So this is the x-intercept, 2, 0. This is another x-intercept, -1, 0. This is the y-intercept. So basically, I'm summarizing everything in one single graph. So does everybody see what we're able to find from a quadratic, just by giving the quadratic general form? I can find the y-intercept, I can find the x-intercepts, I can find the axis of symmetry, and I can find the vertex, both the x-coordinate, which represents the axis of symmetry, and the y-coordinate, which comes from plugging in the axis of symmetry, x value, into my given function. So any questions about this? And so one thing, the y-coordinate, I just want to make a note of this. So the y-coordinate here, this is known as the maximum value. So the maximum value is the largest y-coordinate, which is 9/4. So this is the largest y-coordinate of the function. And alternatively, the minimum value will represent the smallest y-coordinate, which would indicate that it's a minimum. But in this case, we don't have a minimum because you can see that the arrows here point all the way downward. So it goes on forever to negative infinity. And there's 2 more things, actually, before I go. There's 2 more things. So not only can I figure out the x-intercept, the y-intercept, the vertex, the axis of symmetry, we're also going to be concerned with what is the domain, of course, and what is the range. So what's nice about quadratic functions is that you're never going to have an issue with the domain. The domain is always going to be negative infinity to infinity. So that's going to be always the case because you can plug in any x value into my function because of the nature of the function. It's a polynomial. So it's very nice in that regard. There's no bad x value points. However, the range is not always going to be that clear just based upon the first look at the function. You're not going to be able to tell immediately, oh, yeah, the range is so-and-so, right? If you know that it's a quadratic, you know immediately that the domain is all real numbers. But with the range, you have to do all this work, particularly with the vertex. So can anybody tell me what would be the range to this particular function? Negative infinity to 9/4. Very good. That's right. So it's going to be negative infinity to positive 9/4, and we're including it. Now, why is that? Well, remember, the range includes all the y values. And so if you look at the graph of this function, all the y values come from the negative infinity or go to negative infinity because of the y value, because of the arrows pointing downward. And then what's the maximum y value? Well, the maximum y value is exactly the y coordinate associated with the vertex. So the vertex is what tells us the endpoints to our interval for the range. So in general, domain, I'm just gonna write domain and range in general for quadratic functions. So the domain will always be negative infinity to positive infinity. This happens always, right? Always true. This is always true for quadratic functions. However, the range will depend upon a few things. So, so if the following happens, if the a value is negative, then the range. Now, why do we care about whether the a value is negative? Well, if the a value is negative, that means I have a maximum. And if it has a maximum, then my range will be negative infinity to the y coordinate of vertex. And I'm going to include it. And this will be also known as, aka, the maximum value of function. So if my a value is negative, then I have a maximum point, and that maximum point will be the highest y coordinate, which will represent the endpoint to the right of my range. However, if my a value is positive, then I would have the opposite. I would have a minimum, and then my range will look a little bit different. I'll have instead the y coordinate of the vertex on the other side of my interval. So be equal to y coordinate of the vertex. But instead of going to negative infinity, because it's a minimum, I'm going to have a unbounded function going upward. So I will not have a maximum, and I'll have a minimum instead. So this will be aka the minimum value of the function. Okay, so if we have a minimum, then that will be the y coordinate that represents the smallest y value. And so therefore it will be on the left side of the interval range, and we will be including it. And then we'll have the opposite if it's a maximum. Tanzilla, why isn't the range negative infinity to 9/4 union 9/4 to infinity? Well, let's go back. If you look at the graph of the function, the quadratic that we're starting with, we're only looking for the y values of this function. If you notice, this is the maximum y value, right? Isn't it? Isn't 9/4 the maximum? Meaning, what does it mean by the word maximum? There's no bigger number. So I cannot include anything above 9/4 since it happens to be the maximum. So I can't include union 9/4 to infinity because the graph doesn't continue on. It stops. It reaches the maximum, and it goes back down. So the range is only going to be up to the highest y value, which happens to be 9/4 or 2.25. So this is 2.25. Does that make sense? We're not including that other half. Okay. Okay, so this example here, basically we've exhausted all of the information that we can possibly find from a quadratic. We literally found everything we can possibly find. We found the maximum value, we found the vertex, the axis symmetry, the x-intercepts, the y-intercepts, the domain, the range. We literally have done it all, which is great. Now we're gonna continue talking about quadratic functions, but now we're not going to talk about the general form anymore. We're going to be talking about what's called the standard form. So again, the parabola hasn't changed. The sketch of the graph hasn't changed. That has not changed. But now we're going to be talking about a different form. This is called the standard form. The standard form of a quadratic function this is also known as aka the vertex form. And it looks a little bit different from the general form. That's the vertex form, or in other words, the standard form, as your textbook calls it. Now, is this different from the general form? Intrinsically, no. It's representing the same quadratic function. Pardon me for that. I don't know who'll be calling me right now. But what I'm saying is that, is this different from the general form? In terms of what the graph will represent, it's not any different because it's still representing a quadratic function. So you know already that it's going to appear as a parabola. And this a value is the same a value as the other a value that you found. So this is still going to be the leading coefficient. So this information will still be the same. If it's positive, opens upward, minimum. If it's negative, opens downward, maximum. So that a value still gives you that same information. Now we have something a little different though. We have this h and we have this k value. So what are those h and k values going to give me? I don't have the b anymore and I don't have the c anymore. Now, if you pay close attention to this, this is really stemming from, so this is just just like a background info, some background. If you consider the parent function for all of the quadratic functions, what is it? Isn't it y equals x squared? Isn't y equals x squared the simplest kind of quadratic function? And in a sense, every other quadratic function comes from a transformation of this parent function. If you notice that, then you would notice that the quadratic function written in standard form is a transformation, that the transformations that are applied to the y equals x squared, to the parent function. So you can say that the standard form demonstrate or represents the transformations applied to the parent function. Does everybody see that? That's why we talk about parent functions, Because then you can start to see that, oh, the A value, what does the A value do? It tells us whether we vertically stretch, vertically compress. If it's a negative, it tells us whether we flip or reflect across the x-axis. The H will indicate whether we shift to the left, shift to the right, and the K value will represent whether we move up or move down. So because we can move up and move down, and we can stretch and compress, right? That information can be easily discussed. And the H value will indicate particularly what's called the X coordinate of my vertex. And the K value will represent the Y coordinate of the vertex. If you notice, what's the vertex for y equals x squared? The vertex is what? 0, 0. And so when you move something to the right, for example, 3 units, then the vertex is going to change from 0, 0 to 3, 0. And if you move it upward by 1, it's the same thing as saying take the vertex, move it 3 units to the right, one unit up, and you get 3, 1 being my vertex. So that's the reason why these H and K values indicate exactly what the coordinates are for the vertex. Okay? Does that make sense? Do you see the connection between the standard form and transformations of the parent function? So that's important to see. Okay. So now what we're going to be concerned with, what we're going to be concerned with is how to go from general form to standard form. So how do we convert the general form to standard form? So to go from general form to standard form, we have to do a very special algebraic technique. And I'm pretty sure, or I assume that most of you have seen it before. And it's the completing the square method. So that's what we're going to be doing. We're going to be completing the square. So I'm going to give you an example. Let me find, see if I can find one that's good. Yeah, okay. So let's say I give you a function like this. F of x is equal to x squared minus 2x plus 3. Now, this is in what form? This is in the general form. Correct? I know my a value is 1, my b value is -2, my c value is 3. So let me just write that as well. So I know that my a value is 1, my b value is -2, and my c value is 3. Okay. But what I want to do is I want to rewrite this in standard form, which is a comma x minus h squared plus k. Okay, so then what that entails is that I need to look at the first 2 terms of the standard form of the general form, and I want to complete the square. Complete the square. Does anybody remember how we complete the square? Gabriel, we're not equaling anything to 0. So, okay, so there's one thing I want to clarify with that. A function is distinct from an equation. An equation is when you have an algebraic expression set equal to some number or some other algebraic expression. In this case, we do have something equal to one another, right? But really what we're saying is that the function f of x is this algebraic expression. We're not setting this as a number. We're not. It's like we're naming the function. We're saying, hey, f of x, that function is called x squared minus 2x plus 3. So in a way, this equal sign, you can think of it as like is like assigning a name to a function, which is quite different from saying it's equal to a particular number. So that's why we're not setting it to equal to 0 just yet. But completing the square, does anybody recall how we complete the square? And I think that's what you're trying to answer, right, Gabriel? You're saying that you have to set it equal to 0, but you don't necessarily have to set anything equal to 0 to complete the square. You normally, I think, have seen this in the context of having something equal to 0. So you may assume that, oh, I need to equal to 0. But to complete the square, the act of completing the square has nothing to do with equaling anything to 0. Yeah, I think this was part of the exam. One of the questions was dealing with circles, and you had to complete the square for the circles. So if you all don't remember, what we're trying to do when you say complete the square, I know it sounds a little bit like strange, but completing the square is really saying create a perfect square trinomial. That's what we're really trying to do. We can also show this geometrically as to why we say call it a square, but we're trying to create a perfect square trinomial. And you'll see why we even want to do this. At the very moment, right, x squared minus 2x, this is not a perfect square trinomial. So what do we do in order to create this? To create from this a perfect square trinomial. So this is not a perfect square trinomial. Not a perfect square trinomial. So how do we do it? Well, it's also not too bad. We take the number in front of the x, which is a 2. We're going to divide it by 2, and we're going to square it. That's the step. So what is it again? So to complete the square, do we create a perfect square by what? By taking the coefficient of the x term and adding and dividing it by 0. I mean, dividing, not by 0, dividing it by 2, and then squaring it. And we tag it along by adding it. Now, do you see why this becomes a perfect square trinomial? So I go from this, and then what happens? This becomes x squared minus 2x plus what? 2 divided by 2 is 1. If I square it, I get 1. This is what? A perfect square trinomial. Now, the question you should ask is, why is it a perfect square trinomial? What makes this a perfect square? Well, do you guys remember what perfect squares are? For example, 16 is a perfect square. Why is 16 a perfect square? It's because right, because 4 squared is 16. So in the same breath, why is x squared minus 2x plus 1 a perfect square trinomial? Well, something squared must give me that, right? Exactly, -1 and 1. What are you really trying to say? You're trying to say that you can factor this as what? X minus 1 multiplied by x minus 1, right? When we factor the trinomial, we see what adds to -2 but multiplies to +1. It happens to be -1. But if you notice, x minus 1 and x minus 1 are exactly the same. So I can really write this as x minus 1 parentheses squared. That is why it's a perfect square trinomial, because I can write it as a square of, in this case, we call it a binomial, a polynomial with two terms. And that is why it's a perfect square. So do you see how by completing the square, I'm able to get what's the x minus h squared term? I'm able to get this term here. Do you guys see that? So that's why completing the square is an essential part to this. Okay, so we did like a little deep dive into completing the square, but let's still go back. We haven't completed our objective yet. Let's still go back. We want to create the standard form from the general form. So what we're able to do is say, hey, look, x squared minus 2x. I'm just going to replay this again. I'm going to add a 1. I'm going to add this 1 because I got the 1 from taking the 2, dividing it by 2, and squaring it. I got the 1. And then this became a very nice perfect square trinomial. And I could write it as x minus 1 squared. Now, what did we forget? We forgot that there's a plus 3 out there as well. That plus 3 did not go away. And now this is the tricky part maybe to some. I added this plus 1. In the sense, I added it out of thin air. I just said, hey, let's create this perfect square trinomial and let's add by 1. And to do so, and because I did it, I just added this plus 1 out of nowhere. This should not be here. If you add a plus 1 just out of nowhere, then it changes the whole function. Because of that, I need to offset this plus 1 that I just created. So what do I do in the same breath? I need to also subtract by 1. Does everybody see that little step? I must subtract by 1. Why? Well, what's 1 minus 1? 0. So in a sense, because I added by 1 and I subtracted by 1, I added by nothing. So I have not changed the function itself. I've only changed the way it looks. So now the result will be what? F of x is equal to x minus 1 squared plus 2. And I'm done. This is the standard form, aka the vertex form. Do you see that? And then what's my vertex? What information can I gather? I can gather the vertex. What is the vertex? Well, what kind of transformations are being applied? Right, Chen, it's 1 comma 2. What's the transformation here? That minus 1, remember that minus 1 when you subtract it to the x value, shifts it to the right. So then my minus 1 will become a positive 1 for the x coordinate of my vertex. And then the 2 value will be the y coordinate. So it's going to be 2. Does everybody see that? So this is a crucial part, guys, to figure out the standard form from the general form, is the completing the square method. And when you add this plus 1 to complete the square, you must subtract that same thing, because I'm not changing the inherent function. I'm just changing the way it visually algebraically looks, so that I can have the standard form, also known as the vertex form. And from this form, I can immediately gather what the vertex is. So just in general, if the function is a parentheses x minus h squared plus k, then the vertex has the coordinates h comma k. So if the h value is a negative, then the x coordinate will be a positive. If the h value is a positive, the x coordinate will be a negative. So make sure you keep that in mind. But the y value is exactly what you see. So if you see a positive, then the y value is also positive. If you see the k value being negative, then the y value will also be negative for the vertex. So far, so good. I hope we're all good with this. Okay, now I'm gonna give you another example, and this time this example also requires something a bit further. So if I'm given the example like this, if I'm given f of x is equal to 2x squared minus 12x plus 13. Again, this is in what form? General form, right? I want to convert this to standard form. Now, what do we normally do? We say, okay, take the first two terms here and complete the square, right? So I want to complete the square. Now, if I want to complete the square, I have to do something I have to do one step before. Now, normally, what do we say? We say, oh, take the number in front of the 12, divide by 2, and square it. That's what we normally do. But the problem arises when the a value or the number in front of the x squared is no longer a 1. It's something other than 1. In this case, this is 2. So complete the square, but be careful with this. So this is when the a value is not equal to 1. So when my a value is not equal to 1, I have to do one extra thing. I have to factor out. I have to factor. So when this is true, factor out the a. So then I'm going to factor out the a first. So this is 2 parentheses x squared minus 6x. And I'm gonna leave some space because I'm gonna complete the square. So does everybody see that? I have to factor out the 2 from both the two terms. And now I'm really looking at this thing here and saying complete the square to this. And we know how to do that now because we take the number in front, which is a 6. So put this in different colors. I'm gonna put this as 6. I'm gonna divide it by 2. I'm going to square it. And I'm adding this, of course. So what's 6 divided by 2? It's 3. And what am I doing to the 3? I'm squaring it. And so when I do that, what happens? I get x squared minus 6x plus 9. Whoops. Sorry, I think my this just it kind of just died on me. Very weird. So this is plus 9, right? And then this becomes a perfect square trinomial. And then how do we factor x squared minus 6x plus 9? What does that factor into? Does anybody know how to factor this? X minus 3 squared. Very good. Very good. So this becomes x minus 3 squared, correct? Okay. So remember, we just took that little term here. We just took these two terms and we completed a square. So we found that this term here can be rewritten as 2x minus 3 squared. However, we have to be a little bit careful when we actually go through it. Was it plus 3 again? Plus 13. Okay. So what do we do here? Again, I'm just going to do the play-by-play again. I'm saying, hey, I'm going to take this guy here. I want to complete the square. First thing I do is factor out the 2. I get x squared minus 6x. Then what do? I add the 9, right? Now this is when it gets a little tricky, but just stay with me. Then all of a sudden, this is a perfect square trinomial. And I can factor this, right? I can factor this as x minus 3 squared. Okay, but there's a problem, right, guys? There's a problem here. Why is there a problem? I added this plus 9 out of thin air once again. So if I added this plus 9, I don't want to just add the plus 9. I also want to off balance that plus 9 with what? What do you think I'm supposed to do here? I have to subtract the 9. Now the question is, how or where do I subtract the 9? So we have to be careful with that as well. So when I added this 9 inside the parentheses, it's very, very important. I must also subtract the 9 as well. Okay? Because this is really what again? This is equal to 0. I didn't change the function at all. Again, I'm just changing the way it looks. So then now this here, if you combine these terms together, I get this, right? So there still should be a minus 9 here. And there still should be a set of parentheses around them. Again, this is like the tricky part. And we're almost there. Now, you see this extra set of parentheses. I want to get rid of it because I only need one set of parentheses. So what am I going to do? I'm going to distribute the 2 to the two terms that are inside this blue set of parentheses. And so what do I get? I get 2 multiplied by x minus 3 squared. I'm not going to distribute the 2 inside. Why not? Because I already have it in vertex form, which is what I want. 2 times negative 9 becomes what? Negative 18 plus 13. Then I can combine these like terms. Negative 18 plus 13 becomes minus 5. And so then I have successfully converted the general form to the standard form. And from the standard form, what could I figure out? I can figure out the vertex. So what's the vertex of my function? What are the coordinates of the vertex? Three comma negative 5. Very good. Done. And so someone asked, Chen, x squared minus 2x, all I have to do is divide by 2 to get x squared minus 3. Yeah, but you have to be careful though. You're taking 6, you're dividing it by 2, but you're squaring it. And you get 9. And then you notice that, oh, I get the 3 back anyways, right? 6 divided by 2, I get it back. You just have to be careful when you have numbers that are not even. So like if you get like a 5 instead and you want to complete the square to that, you still have to divide it by 2. But in that case, it's going to be 5 halves. It's not going to be like a whole number like the way we've been doing. So for the most part, we've been doing even numbers, which are pretty nice because there's no problem, right? So you just have to be careful though with that step of taking the middle number, dividing it by 2, and squaring it. You have to always be a little careful with that. In the step where you factor into a square of a binomial. But if you guys understand the whole adding and subtracting business, then you should be okay um, for this particular kind of thing. So then we're able to figure out the factor. I just had to divide by 2. Yeah, if you when you factor the 2, you divide everything from these two terms, right? We do divide it by 2. So based upon my standard form, I'm able to find my vertex. And not only that, guys, what else can I figure out? I can figure out the axis of symmetry. Does anybody know what the axis of symmetry is? X equals what? Chen, yeah, you're saying from x squared minus 6x. Uh, that's not necessarily true, right? You didn't divide if you given what you told me, the x squared minus 6, so x squared minus 6. If you divide this by 2, I do not get x minus 3 squared. That's not what happens. So make sure you keep the steps one by one. I don't Gabriel, I don't understand. What is AOS? AOS is -3. Oh, axis symmetry. Got it. Axis symmetry. Axis symmetry. Yes, that's right. That's right. Axis symmetry is x equals 3. That's very good. Very good. The reason why is because the remember the x coordinate for my axis for my vertex, the x coordinate is the axis of symmetry. So x equals 3 is the axis of symmetry. So don't forget that. How the symmetry is related to the how axis symmetry is related to the vertex and how the vertex is related to the axis of symmetry. And then what would be my max value? Or do I have a max value or do I have a min value? So what do I have? Do I have a min or max? I have a minimum because my A value is 2. So I have a minimum. So then I'm going to ask, what is my minimum value? What is the minimum value of the function? So what is the minimum value? So I'm going to call this like, this is like part A, this is part B. What is the minimum value? The minimum value is -5. That's right. My y value is -5. The minimum value is represented by the y coordinate of my vertex. So then part C, can you tell me my domain and what my range is? See, I didn't even have to graph anything, and I already know what the domain and range is. So the domain is obviously going to be what? The domain is always going to be all real numbers. What's the range though? What would be the range? -5 to infinity. That's very good, Tiffany. Yes. It'll be -5, including all the way to positive infinity. Because we're going exactly by what we said here, right? If my a value is positive, then the y-coordinate of my vertex will be the left endpoint of my range, and I'm including it all the way to infinity. That's exactly right. Very good. Very good. Okay, so any questions at all about quadratic functions? The general form, the standard form, the vertex, the axis of symmetry, the minimum value, the maximum value, the domain, the range. So we've discussed all of this. Okay. So now that we have all of this down pat, we're able to sketch it. We want to see the applications of the quadratic. So we're going to look at the applications. Of quadratic functions. So AKA quadratic modeling. So we're going to look at the applications of this. Okay, so I'm going to give you an example. A ball is thrown directly upward with the initial velocity of 40 feet per second. Okay, so I throw a ball up, straight up with an initial velocity of 40 feet per second. And its height in feet after t seconds is given by the function h of t is equal to 40t minus 16, 40t minus 16t squared. Okay, so this is my function that tells me the height of the ball after t seconds. And then the question is going to say, what is the height? Or I should say, what is the maximum height? What is the maximum height of the ball? So the key thing here is to notice, that this is a what? It's a quadratic function. If you notice that, you're in the game. This is a quadratic function. The moment you see the t squared, it's quadratic. I want to find the maximum height. So this word here, maximum height, seems to refer to something that we've known, right? The maximum height will indicate the vertex of parabola. Doesn't that make sense? So if I find the vertex of the parabola given by this function, then I will surely be able to find the maximum height. Of course, you can say, oh, I'm just going to graph this and find a maximum. But you don't have to use a graph to solve this. So I want to find the vertex. Now, how do I find the vertex? And before I ask that, the quadratic function that I'm given, is this function in standard form or is this function in general form? Which of the two? So is this in standard form or in general form? So notice what? Notice that h of t is in blank form. So what form is h of t in? It's in the general form, right? So if you look at the general form again, what's the general form? F of x equals ax squared plus bx plus c. So if you want, we can rearrange the numbers here. So h of t is negative 16t squared plus 40t, right? I just switched around the order of these terms because the x squared term is usually first. So you should be able to do that without blinking an eye. Okay, so based upon that, then what do I know? I know what A is, I should know. I know what B is, I should know. And I know what C is, right? What's my A value? My A value will be negative 16. What's my B value? 40. And what's my C value? 0. So that's a lot of information right there. This is A and this is B. Okay. So I noticed that h of t is a general form. I noticed that h of t, I can break down and got the A, the B, and the C value. Now, what am I going to use the A, B, and the C value for? Again, what's the goal of my problem? I want to find a maximum height. How do you find a maximum height? I'm really trying to find the vertex. To find the vertex, what must I first find? To find the vertex, what must I do? Find what? I need to find the, remember, the axis of symmetry. Because the axis of symmetry gives us the x value to my vertex. So instead of calling it x negative b over 2a, because my variable is a t, I'm going to call it t. T equals what? Negative b over 2a. What is this going to be? Negative 40 over 2 times negative 16, which is negative 40 over 32. Divide by 8, and I get this is negative 2, right? So this will be a positive 5 over 4, which is what? 1.25. So that's my axis of symmetry. And this will be the, in this case, the t coordinate of my vertex. So now that I found the t value, how do I find the maximum? Find the maximum value. What do I do with this? How would you find the maximum value now that you know the t value or the axis of symmetry? Right, you plug in. So then my function is what? H of t. So I plug in. I'm going to plug in the fraction form, 5/4. So this would be negative 16, 5 over 4 squared plus 40 times 5 over 4. And the reason why I use this instead is because fractions are a little bit easier to deal with this when you multiply it out like this. 5/4 squared is really what? 25 over 16. And this is, the 4 here cancels with the 40 and I get 10. So 10 times 5 is 50. So 5/4 of 40 is 50. The 16s here cancel as well. And I'm left with what? Negative 25 plus 50 equals positive 25. So then what did I just figure out? I figured out that the vertex has the coordinates what? 1.25 comma 25. That's my vertex. I found it. Now I need to interpret this vertex. What's the interpretation of the vertex? And to do this, I need to figure out what is this h of t business here? What is this h of t? When I write this, right? When I write this here, what am I saying? T is what? The time in seconds. And h of t, the output represents what? The height. So if I write this in coordinates, right, what would be the coordinates? T comma h of t. Or in other words, the time comma the height. So then what am I saying with 1.25 comma 25? After or at the time 1.25 seconds, the ball reaches its maximum height of 25 feet. And so there I found my answer, didn't I? It says, what is the maximum height of the ball? Well, the maximum height of the ball is 25 feet. And when does it happen? It happens after 1.25 seconds. So any questions about this? Any questions at all? Oh, did I do plus? Oh, yes, I did. Sorry. Thank you. Thank you, Tiffany. So this should be just a minor little thing here. This should be plus, this should be minus. That's right. No, 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 no. This is fine. This is fine. Right? Oh, I mixed up. Oh, I see what I mixed up. You're saying I mixed up this? Yeah. I mixed up. So this is the original graph. This is the original function that they gave us in the beginning. So thank you. But any other questions about the whole idea behind applying quadratic functions to real world examples, such as this one? And just to give you a better visualization of it, you can graph h of t, right? Can't you do that? Because I know my a value, b value, and c value, I can figure out several things quickly. For example, I can figure out what is the y-intercept. So again, this is gonna be t value. What's the y-intercept? Well, the y-intercept is 0. Why is the y-intercept 0? 0 because my c value was what? My c value is 0. So I know that's my y-intercept. And at the same time, my y-intercept, because it's 0, 0, is also my x-intercept. What's the other x-intercept, or the t-intercept in this case? So what would be the other t-intercept? So the t-intercepts, remember the t-intercepts is in what equals 0? When the output equals 0. So if I do 40t minus 16t squared, that equals 0. What I could do here is I can factor out the t, and I can factor out an 8. So 8t, if I factor out an 8, I get what? 5t minus 4. Sorry, 5 minus 4t. This equals 0. So then look what I get. I get that t equals 0, and I get that t equals 5/4. Sorry, this should be 2 if I factor out an 8. I get 5 halves. 5 halves is what? 2.5. So at 2.5, I got the intercepts. And at 1.25, what do I have? I have the axis of symmetry, and at the axis of symmetry, the y value associated with the axis of symmetry is 25. So then this would be the graph. And again, this is time. And again, this is what? Height. So at 1.25 seconds, the height is 25 feet. Does everybody see that as well? We can also graphically, maybe visually, sometimes it's a little better to understand than just algebraically speaking. But exactly what I've done with the algebra before this, all of this is exactly associated with the graph. And you can tell, oh, the graph of the height with as time goes on, right? That height is moving in a parabolic manner. And it makes sense that if this is 1.25 seconds, then if it takes half the amount of time to get up, then it'll take the same amount of time to go back down. So that's why you double the time, and that will be when the height is again in the original position. So any questions about this? Okay, any questions? No questions? Okay. If no other questions, then we can move on to the next kind of. So again, there's so many different applications to the quadratic, to real world examples. A lot of things that happened in the world in nature has quadratic, especially when we talk about, like, for example, parabolic motions. Of course, the word parabolic indicates quadratic. So anything that you throw in the air is going to move in a parabolic manner. But of course, we can also use other situations that arise. So, for example, if you have a rectangular yard, right? Let's say you wanna enclose. So you want to enclose a rectangular area with 2,400 feet of fencing, a fence, of a fence. So you have 2,400 feet of of fencing, sorry. Now, what you want to do is you first want to figure out, what you want to do is you want to figure out what are the dimensions that you need to maximize the area. So I want to find the dimensions of rectangular area to maximize its area. The question is, you don't know what it is, right? So you can give it a drawing. You can make a drawing and you say, okay, this is my rectangular area. Now, do I know the dimensions? Of course not. I'm looking for what the dimensions are. But what do you know? You know that whatever the rectangular area would be, whatever this area would be, you know that you're going to enclose it with what? You're going to enclose it with 2,400 feet of fencing. Now, what does that indicate? If you have 2,400 feet of fencing, what is this? What is an alternative way of saying this? You don't know the area, but you do know what? Starts with the P. You know the perimeter. That's right. So when we deal with these kind of problems, guys, you have to be able to translate things into mathematical terminology or into mathematical equations. So we're interpreting that the rectangular area has a perimeter for the fence, right, of 2,400 feet. So we know the perimeter of this guy is 2,400 feet. Now, what is the perimeter How do you find the perimeter of a rectangle? You add up all of the sides, right? Do you know what the sides are? No. So because we don't know what the sides are, what do you think we're going to do? Whenever we don't know something, or we don't know or we have an unknown quantity, what do we create, or what do we utilize? We have to use what? Variables. That's right, Chad. We have to use variables. So then what are we going to say? We're going to say this. Let what? Let x equal the width of rectangle. Okay, so if that's the case, and this is going to be what? This is going to be x. This is going to be x. Now the question is, what's going to be this side? And what's going to be this side? What's going to be the length of the rectangle? Can someone tell me how we figure out the length? Of course, we're going to set it equal to, we're going to write it in terms of x, right? So Tiffany, it's not 2400 minus x. So remember, the perimeter is x plus unknown plus x plus unknown. And they all have to add up to what? 2400. So in reality, one way you can do is this. Look, you can call this y. For now, let's just call this y and call this y for now, okay? So then we know that the perimeter is what? The perimeter is 2x plus 2y equals 2400, isn't it? Then you can factor out the 2 and you get 2 parentheses x plus y equals 2400. Divide by 2, and I get x plus y equals 1200. So x, which is the width, plus y, which is the length, have to add up to 1200 somehow. And now look what I can do. I can solve for y. If I solve for y, what do I get? I get y equals 1200 minus x. So I can rewrite y. I can really rewrite this as what? 1200 minus x. And this is going to be 1200 minus x. Do I know what x is? I don't know what x is. But whatever x would be, then this would be 1200 minus that value. So now I can replace this with 1200 minus x. Because when I add all these up, when I add them all up, what do I add up to? It adds up to 2400. Okay, so that's like the hard part. This is the hardest part, is setting it up, is finding the right variables, is interpreting the context of my problem. That's the hard part. But now once we have that, can't we figure out what the area of the rectangle is? How do you find the area of a rectangle again? Anyone? What's the area of a rectangle? It's going to be the length times width, right? So this is the length multiplied by the width. But what is the length? It's 1200 minus x. What is the width? It's x. And I'm going to call this the area. I'm going to call it a of x. Now, what do I have? When I distribute the x, I get 1200 x minus x squared. What is this? What kind of function is a of x? Anybody? What kind of function did we just discover for a of x? The area. The area function is a what kind of function? It's a quadratic. That's what it is. It's a quadratic function. Yes. It's a quadratic function. We know all about quadratic functions. We've been talking about quadratic functions for the past almost 2 hours. And what are we trying to figure out? We're trying to find what? We're trying to maximize the area. Well, we got the area function, which is a quadratic function. So what are we supposed to find? Given the quadratic function, to find the maximum area, we're going to have to find the vertex. So to find the maximum area, we must find the vertex. A parabola. How do we find the vertex of the parabola? I'm given the function that's quadratic. So what's the first step? To find vertex. Now this should be clockwork now. This should be instinctive. Whenever we want to find a vertex, we must find first what? The axis of symmetry. What's the axis of symmetry? X is equal to what? Negative b over 2a. What's negative b? What is my b value? Can anyone tell me what my a and b and c value are? What's my a, b, and c value really quick? So we should be able to scan this and then immediately get it. That's right. So a is -1, b is 1200, and c is 0. Plug in, you get what? You get -1200 over 2 times -1 is -1200 over -2, which equals 600. So x is 600. That's the x coordinate of my vertex. And my vertex is going to be what? My vertex will be a maximum because my a value is what? Negative. This means I have a maximum point. So if my x value is 600, then what's going to be the y value? Or what's going to be the maximum? What's going to be the maximum value? How do I find the maximum value? I plug in a of 600, and I get 1200 times 600 minus 600 squared. So 1200 times 6 is what? 72, and this is going to be what? This is going to be 72. 1, 2, 3, 4. So it's 720,000 minus 600,000. 600 squared is going to be 360,000. So if you subtract that, you get 360,000. So what does the maximum value represent? It gives you the maximum area. The maximum area will be, and this is in feet, right? So if it's in feet, that means that the area will be feet squared. So this is the maximum area. Maximum area of rectangular field. What does this mean? This means that if I have 2,400 feet of fencing, the maximum area that I can enclose is 360,000 square feet. And that's a fact. As long as the field is rectangular. And so then now the question is, what are the dimensions of this field? What are the dimensions of the maximum field? Of rectangular field with maximum area. Well, what do I know? I know that 600, it represents what? What does 600 represent? 600 represents the x value. And what does the x value represent again? The width. So I get a maximum area of 360,000 square feet when my width of the rectangular field is 600 feet. So then my width has to be 600 feet. But then what would be my length? If my width is 600, what's my length? Remember, what is the length of the rectangle? It's also going to be 1200 minus x, which is 1200 minus 600, right? And what's 1200 minus 600? It's 600. So it just so happens that if I create a square, which is still a rectangle, that's why I still call it a rectangle. If I create a square of 600 feet on both sides, I create a maximum area. Any other rectangle, any other rectangular dimension that's not a square is not going to create a maximum area. So these are my dimensions. So again, if I create a square where each side is 600 feet, I have the maximum amount of area enclosed by the fence. Any other dimensions would not produce a maximum area. And that's how we can also utilize quadratic functions. Quadratic functions are great when you have two different variables that can be interchanged with one another, and you can find the maximum or the minimum of it. Chen, a square is a rectangle. A rectangle by definition is a quadrilateral that's a parallelogram where the opposite sides are the same. So sure, most rectangles do have a longer dimension than the other one, right? They do have one side bigger than the other one. In general, that's your idea of rectangles. But under the conditions of a rectangle, a square satisfies every single one of them. So the way people usually say this is all squares are rectangles, but not all rectangles are squares. So that's the general idea. So when I say a rectangle and I get dimensions that are the same, it's still a rectangle, but we call them squares. But not every, so you understand that? So not every, I'm going to say, not every rectangle is a square. All squares are rectangles. That's what I meant to say. Okay. All right. All right, guys. So I'm going to stop here with the recording.